In this question, we're going to take a look at using the sine rule to find a missing angle. So the reason why in this case I'm opting to use the sine rule rather than the cosine rule is there's two angles in the question that I need to involve. So I'm going to go down the sine rule path. If you're not sure about the logic and the thinking around picking a formula, I have a video of that on the YouTube channel. If you go back and you just look for trigonometry and in the playlist you will find the first video is how to choose a formula. So it's a triangle that's not a right angle triangle, or at least I can't confirm that it's not a right angle triangle, so we opt for two things, either the cosine rule or the sine rule. If you know all of the sides, you can go down the cosine rule pathway. If you are looking at angles, you've more information about angles, or there's at least two angles involved in the question, one that you're given, one that you're looking for the sine rule. So first step, as always, is we write down the formula. And if you've written down the correct formula in this question, you get 40% of the marks. So the sine rule is the formula we're choosing. In your log tables, it's given as a all over sine A is equal to b all over sine of b is equal to c all over sine of c. Now they don't tell you this in the log tables, but it's a fact, and you can test it out using algebra. You can actually write these all as the angle on top. So we can go sine A all over A is equal to sine of B all over B is equal to sine C all over C. That's our formula. I don't actually need to use the B one because we're not given information about B, so we can cut out the middleman literally here, and we can say, right, sine A all over A is equal to sine C all over C, and that's perfectly fine to ignore this one here. It's just showing us the relationship between them, that they are all equal. We only need to use the fact that the A and the C ones are equal to each other. There's our formula. Next thing we need to do is write down our information. Now what you need to know is about the labeling of these. The angle A is always across from the side you're going to call A. So that is side A. So we're going to write in, first for the information, capital A is the angle, and the angle is 30 degrees. The side A, which is across from it, is going to be the side A, which is lowercase a. So angles are always given capitals, and lowercase letters are the sides. Capital C is just capital C in this case. That's what we're working towards finding out. And then the lowercase c is always the side across from it. So lowercase c is 3. So there's our formula, there's our information, then we fill it in. So into that formula then, we're going to have sine of 30 all over A, so all over, and then A is going to be 4.65 is equal to sine C, so we're going to go sine C all over 3. Because it's all over C, which is the lowercase c, which is 3. So now I've got my formula, I've got my information, I've filled it in. In this particular exam question, it was worth 60% of the marks to fill it in correctly. So we're at 60% already. The next thing we can do is, I want to work towards having this sine C on its own. So let me multiply both sides by 3 here. Now, you could, if you wanted, put that in your calculator, but I guarantee you, if you put that in your calculator, it probably won't be so nice right now. But if I multiply both sides by 3, and you can put maybe that in your calculator, I'll tell you this time it does work out to be nice. So if you do sine of 30 all over 4.65 and you multiply it by 3, you get actually quite a nice answer of 10 over 31. And then we get that sine of C is equal to that. Right, so this is the process of working out our answer. I want to get C on its own, to get the angle on its own. What we need to do to get the angle on its own is get rid of the sine. What is the opposite or inverse operation of sine? It's sine inverse. Okay, so I'm going to get sine inverse of both sides. So then I'm going to have sine inverse of 10 over 31, and it's equal to C, because sine and sine inverse will undo each other, they're inverse operations. And if you chuck that into your calculator, you will get 18.819 da da da. They asked in the question, they asked us to give it to the nearest degree in the exam question that time, and so you'd have to make sure, reflecting on the answer stage, did I give it in the correct form to make sure I got my full marks? So you get 19 degrees. If you didn't get it rounded, you would have lost a mark. Okay, so really, really important. You must have it rounded to the correct level of specificity. So that's the sine rule. Again, it's in your log tables. You don't need to recall it. You do need to know, however, when you need to bring it into play. And the other thing that you maybe just would wish to try and remember is that you don't need to use all three of them. You only choose the ones that are relevant. And you also need to know that you can rearrange it. Can be rearranged. Why would you want to do that? Makes the algebra so much easier at the end. If my sine was on the bottom here, I'd have to do a lot of rearranging. So I would say if you're looking for an angle, immediately swap it so that all the sines are on the top.